Lesson 7, the relationship between visual fraction models and equations. Goal: connect models of fractions to multiplication through the use of multiplicative inverses as they are represented in models. So first I want to talk about this word multiplicative inverses, that term there. So some of you were wanting to, instead of using models, just go ahead and flip that last fraction by multiplying by the reciprocal, which is what they're talking about here when they say multiplicative inverse. So instead of dividing, you multiply. That's an inverse. And it's a multiplicative inverse because, again, instead of doing the division, you multiply by the reciprocal. So for those of you who really just wanted to do it that way and not the models, you'll see kind of how it relates and how you can kind of do both. But we still need to prove it with models. So our example 1 says 3/4 divided by 2/5. So what we want to think about is 2/5 of what number is 3/4? We're going to go ahead and follow these steps to do our model. Step 1 says shade 2 of the 5 sections so that it shows 2/5. That shows 2/5. Now we want to label that part that's known as 3/4. This is similar to what we did in lesson 2, where we modeled with the second fraction, and then the first fraction was that shaded area. It's the same thing, except for this is not a whole number now, it's a fraction. So this is going to be 3/4. So what we need to figure out is how much would each box get if together it made up 3/4. So I have to divide 3/4 in half. So if you're not sure how to do that, you could even do a model. Okay. And cut it in half. Here is half of that. It would be 3 out of 4/8. So that shows that each of these would represent 3/8. And so to get your final answer, you can see how many boxes you have, and if there are 5, you can multiply that by 3/8, or you can add 3/8 5 times. So I'm going to go ahead and show multiplying. That would be 15/8, but I can rewrite that as a mixed number. I never want to leave my answers improper. I want to always write it as a mixed number. So 8 goes into 15 one time, so 8/8 makes a whole, and then I would have 7/8 left. 1 7/8 should be that answer. Now, there's another way to show 3/4 divided by 2/5. And the other way is common denominators. So we've done this before where we had to find a common denominator. We could say 20. Multiply by 5, so we multiply the numerator by 5. Multiply that by 4 to get 20. Multiply the 2 by 4 to get 8. And so I have 15/20 divided by 8/20. I have 10/20 here, and then I have another 10/20. So I could shade in 10/20. And another 1, 2, 3, 4, 5. This here shows 15/20, and now I want to find groups of 8/20. So the answer would be 1 whole, and there are 7 out of 8 shaded. 1 7/8. Both of those models show the answer. It's really up to you which model you prefer to use. This method for dividing fractions by fractions is called invert and multiply. Dividing by a fraction is the same as multiplying by its inverse, or reciprocal. It's important to invert the second fraction, which is the divisor, and not the first fraction, which is the dividend. Exercise 1, 1/4 divided by 2/3. So again, we're going to model the second fraction. So the second fraction shows 2/3, and this shaded area is worth 1/4. So if that is 1/4, if you split that into 2, I would have 2/8 total, which is the same as a fourth, so I have 1/8 and 1/8. So then this gets 1/8. And so if you have 3 1/8s, you have 3/8. So if you have a fourth, and you're dividing by 2/3, that would be the same as multiplying 1/4 by 3/2, which you can see. You multiply across. 1 times 3 is 3, 4 times 2 is 8, which is the same answer that I got as my model. Exercise 2, 2/3 divided by 3/4. Again, the model is going to be the second fraction. And the 3/4 is going to be worth 2/3. If I have to divide my 2/3 into 3 boxes, again, I can show 2/3 divided by 3. This would be my answer, 2 out of, and if I have a 3 by 3, that would be 9. So 2/9, another 2/9, another 2/9. So that would be 6/9, which is the same as 2/3. So this one gets a 2/9. And so if I were to add that up, I would get 8/9. I can check and make sure that 2/3 divided by 3/4 using the reciprocal multiplicative inverses. 2/3 times 4/3. 2 times 4 is 8. 3 times 3 is 9. 8/9. And now I just have some room for some extra examples. Let's do 3/5 divided by 2/3. So what I would want to do here is show a model of that second fraction. So 2 out of 3. And 3/5 is that 2/3. So I need to divide my 3/5 into 2. If I have 3/5 and I'm dividing it in half, here's one of the halves. It's 3 out of, and if that's 5 and another 5, that would be 10. So I would have 3, 6, 9 tenths. I can show the multiplication, the inverse. Three times 3 is 9. 5 times 2, 10. Same answer. I'm going to do one more. this is going to show my model. My 2 fifths is right here. So that would mean that these are just 2 fifths as well. And this itself is 2 fifths. So if I have 2, 4, 6, 8 fifths, would I leave it as improper? I hope you say no. I would see how many fifths are in 8 fifths, 5 fifths. That would make 1 whole, and there would be 3 left over to make that 1 3/5. I can show the multiplicative inverse to check my work. Multiply by 4 over 1, and I would get 8 fifths. And again, there's 5 fifths making a whole. 3 left over, 1 3/5. Please remember to do your reflection by writing a comment or a question on the left-hand side of your notes. Also rate yourself if you're green, yellow, or red, so you'll be ready when you come into class tomorrow. If you're able to, provide your own example and a model of the answer.